Yeah, tell me, Chandana, have you any requirement?
So,
Can I go in my way?
so
Chandana?
you can continue the class.
Yeah, in order to this quadratic equations, we have algebra of matrices. We have. Do you know, Chandana, algebra of matrices?
No, sir.
Huh? Yes
No,
or no?
sir.
No. Algebra of matrices. Yeah, matrices is a plural form. Matrix is a singular form. Matrix. Yeah, matrix means what? If the complex numbers are arranged in the form of a rectangular shape or a vertical shape, okay, of the complex numbers in horizontal or vertical lines, then the arrangement is called a matrix. Suppose some complex numbers. Complex numbers means whatever it may be, we have to take either natural numbers or whole numbers or integers or rationals or irrationals and real numbers. Of course, complex numbers. Whatever it may be, we have to take. Of course, some elements also. Elements means not only alphabetical, some numbers, alphabetical numbers, and etc. Anything, any values we have to write, or we can arrange some horizontal and verticals. Horizontal and verticals means here this is yeah. In between this brackets, yeah, these are all called elements, whatever it may be. This dash is nothing but, suppose we are taking 1 2 3 4 5 6 7 8, here onwards a b c d, here l m n o. Okay, so this is called a horizontal shape, this is called a vertical shape. Some elements can be arranged in horizontal and vertical. In between this brackets is nothing but, this arrangement is nothing but matrix. Matrix is denoted by capital letter, capital alphabetical orders, that is capital A. So in generally we are writing this matrix should be right like this. Yeah, A11, A12 something. Yeah. Here, how many vertical lines are there? This is one vertical line. Here, this two, second vertical, third vertical, and fourth vertical. Horizontal. This is second horizontal. This is third horizontal. This is fourth horizontal. Now here, how many horizontals are there? Horizontal lines are nothing but rows. Vertical lines are nothing but columns. Columns. Now order of A equals to number of rows by number of columns. Number of columns. So here, in the example, 4 rows and 4 columns are there. This is this symbol looking like into, but we read as by. 4 by 4 it is. 4 by 4. Here, capital A equals to 1, 2, 3, 0, minus 2, 4 here. How many rows are there? One row, second row, column 1, column 2, column 3. First of all, we are writing number of rows, 2 rows into by 3 columns, 2 by 3. Yeah, this matrix having the order That is 2 by 3 order. 2 rows and 3 columns will have this. Okay. Now the general matrix of A is A, which is nothing but A11, A12, A13, etc. up to A1n. Next, A21, A22, A23, etc. up to A2n. Next, A31, A32, A33, etc. up to A3n. Here now we are writing AM1, AM2, AM3, etc. AMN. So this is one matrix. In this matrix, M rows by N columns are there. M rows and N columns. Just in this matrix, we are taking, we will write this matrix in is nothing but A, capital A is equal to, the element is A. In this A, having I rows and J columns. Aij, which is having M by N. I lies between 1 to M. 1 less than or equals to I less than or equals to M. J 1 less than or equals to J less than or equals to N. I and J both are lies between 1 to M and 1 to N. Here A11 means it shows like this. This one is position of this element. This one is column position of this element. Suppose A32 is there. A32 means the first letter indicates row position in that matrix. This is nothing but column position. So finally, we are saying about this A32 means third row, second column element is A. Third row, second column, third row. Here, how many rows? 1, 2, 3, 4, 5, etc. M rows are there. How many columns? 1, 2, 3, 4, etc. M columns. M rows and N columns are there. For example, just I am taking 1, 2, 3, 4, minus 5, 0, 6, minus 2, 5 is there. Minus 5 is there. Minus 5, which is 2, 2, 2. 2, 2 means second row, second column. 1 is first row, first column. 2 is first row, second column. 3 is first row, third column. And 5 is third row, third column. Minus 2 is third row, second column. In this way, we are taking the elements in that matrix and the position of elements in that matrices. Chandra, are you understand?
Yes, sir.
Atiti also joined, I think. Atiti, good evening. Here now types of matrices we have. One is square matrix. Square matrix. Singular form is matrix, plural form is matrices, of course. Square matrix means A is a matrix which has A, I, J elements are there, M by N. That means number of rows and number of columns both are equal in that matrix. Okay. Number of rows equal to number of columns. Number of rows equal to number of columns when a matrix having, then it is called the square matrix. Second one, rectangular matrix. Rectangular matrix means A equals to, suppose Aij. In this M by N, number of rows and number of columns are not equal. Number of rows is not equals to number of columns. For example, here A equals to 5, 6, 7, 8. Here this is 2 rows and 2 columns are there. This is called a square matrix. And the B equals to, suppose 1, 2, 3, A, B, C. Yeah, here 2 rows, 3 columns. This is called a rectangular matrix. This is called rectangular matrix. And its shape also looking like this is a square. Okay, this is a rectangle. Okay, now it is a square matrix and a rectangular matrices. Next, row matrix. Row matrix means A equals to Aij 1 by n. 1 by n means only single row. A matrix having only single row is called a row matrix. For example, A equals to 1, 5, 6, 7. How many rows are there? Only one row. Columns 1, 2, 3, 4 columns are there. 1 by 4. This is an example. Fourth one, column matrix. Column matrix means suppose B equals to Bij m by 1. Single column will be there. Single column. For example, B equals to here 5, 6, 7. Here 3 rows. 1, 2, 3 rows are there. Column is only 1. 3 by 1. So when a matrix having only one row, that is row matrix. A matrix having only one column, that is a column matrix. Row matrix and a column matrix. Next, upper triangular matrix. Upper triangular matrix. Upper triangular matrix. For getting triangular, upper triangular or lower triangular, compulsory we are taking a square matrix. Okay. In a square matrix Aij, which have n rows and n columns, both are same. Okay, is said to be upper triangular. If when it is upper triangular, Aij values are zeros. Whenever I is greater than j, I is greater than j means what? A11, A12, A13, A21, A22, A23, A31, A32, A33. Yes. Just we are taking for example A11, A12, A13. For example, we are taking the square matrix 3 by 3. A21, A22, A23. And A31, A32, A33. Yes, it has 3 rows, 3 columns are there. Okay. Now Aij means these values are 0. When I is greater than j means here this value is greatest to this value. So A21, 2 is greater than 1, 3 is greater than 1, 3 is greater than 1. So these values are zeros. These values are zeros. Simply I am saying about this. In a square matrix, below the diagonal matrix element, the diagonal elements are zeros, remaining all are non-zeros. Diagonal means what? Here A11, A22, A33. These three are nothing but diagonal elements. When this diagonal element under elements are zero, then it is upper triangle. Under 0, upper is not 0. Here A is equal to 0 whenever I is greater than 0. So this is upper triangle. Next, lower triangle here, A21 0, next A31 0, A32 also 0. Lower triangle. Lower triangular matrix means what? Let A equals to same. Aij is a square matrix n by n. If Aij is 0, whenever, okay, J is greater than, J greater than I means the reversely will take. Capital A equals to A11, A12, A13, A21, A22, A23, A31, A32, A33. These the upper values of principal diagonal. So these values are 0, remaining all are non-zeros. This is called lower triangular matrix. Lower triangular matrix. That means A12 equal to 0, A13 equal to 0, A23 also 0. When these values are 0. Yes, for example, I will show you that A equals to 1, 0, 0, 2, 3, 0, 4, 5, 6. Yes, this is called a lower triangular matrix. Okay, the upper values are 0, lower values are not 0. This is lower. Next, A equals to, this is lower triangular. A equals to 1, 5, 6, 0, minus 2, 3, 0, 0, 7. This is called upper triangular matrix. This is lower triangular. This is upper triangle. A square matrix, either upper triangular or lower triangular, is a triangular matrix. Either or it is. Triangular matrix means if A is set, if A is either upper triangular matrix or lower triangular matrix, then it is a triangular matrix. Then it is a triangular matrix. Next, diagonal matrix. Diagonal matrix means if A equals to Aij is a diagonal also square matrix. Compulsory will take a square matrix. In a square matrix, only diagonal elements are not 0, remaining all are zeros. Okay, if Aij equal to 0, whenever I is not equal to j. Okay, that means what? A1100, 0 A22, 0, 0 A33. Okay, I equal to j is not equal. Okay, Aij is not equal to 0 whenever I equal to j. Simply what I am saying here, in a square matrix, the principal diagonal elements are non-zero, remaining all are zeros. Is called a diagonal matrix. The diagonal elements are not 0. The remaining all are zeros. This is called diagonal matrix. It is denoted by D only. Next. Hope you both of you understand.
Yes, sir.
Okay. Chandana, are you understand?
Yes, sir.
Next, scalar matrix. Scalar matrix means the diagonal matrix, the diagonal elements are same. Okay, the diagonal elements in a diagonal matrix, the diagonal elements are same. Suppose A equals to here 5, 0, 0, 0, 5, 0, 0, 0, 5. Okay, that means A equals to Aij. This is n by n. Aij equal to some scalar alpha. Okay, I equal to j. Whenever I equal to j, I j అనేది alpha equal. Alpha అంటే anything, any one scalar. So the principal diagonal elements, all the principal diagonal elements are non-zero. Of course, all are equal to a number, either 5 or 6, whatever it is. So it is a scalar matrix. Next, unit matrix or identity matrix. Identity matrix. In a scalar matrix, the scalar is 1. 1. That means this is indication IA 1 0 0 0 0 1. Sorry, 0 1 0 0 0 1. 1 0 1 0. This is 3 I3 it is. Identity matrix with the 3 by 3. 3 rows and 3 columns. Every unit matrix need not be a scalar. Sorry. Every unit matrix is a scalar, but every scalar matrix no need to unit matrix. Why? Because here 1 is there. Yeah, every one in 4 by 4 also 1 is there. That is a scalar matrix. But a scalar matrix, in that scalar matrix, not only 1, we have 2, 3, 4, 5, 6, etc. So that's why every scalar matrix need not be a unit, but every unit matrix is a scalar. And every scalar matrix need not be a diagonal, but every diagonal matrix is a scalar. Okay, you see that? Are you understand?
Yes, sir.
Next, now equality of two matrices. When two matrices are equal, there will be 2 points are there. First one, if A comma B, two non-zero matrices, for getting these two, the orders are same. The orders are equal. Orders means the number of rows and columns in A, the number of rows and columns in B, both are equal. The next, the corresponding elements will be equal. The corresponding elements are equal. Then A equal to B. Okay. For example, A equals to A11, A12, A21, A22. This is a 2 by 2 matrix. B equals to B11, B12, B13, B21, B22, B23. Here 2 rows, 3 columns will have. So when we can check these two matrices are equal or not. For getting these two matrices are equal, the first point is phase. The orders are equal. Here 2 by 2 matrix, this is 2 by 3 matrix. So these two are not equal. For suppose here this column is deleted. Now here this is 2 by 2. Then the first point is satisfied. The next corresponding elements means if A11 equals to B11, A12 equals to B12, A21 equals to B21, and A22 equals to B22, then A equals to B. Corresponding means here this one and this one. This one and this one. Those two are corresponding elements when the equal, then it is called the corresponding elements when equal in two matrices, then those two matrices are equal. Yeah, you see, for example, x 0 and 2y, 5 x plus y, 6 y. Is there when these two are equal, then we are writing x equal to 5 and x plus y equal to 0. Then what x 5 plus y equal to 0, then y equals to minus 5. X value and y value. So this way we are finding the variable values in the given matrices. Okay. Next, addition of two matrices. Addition of matrices. For taking addition, if A and B, two non-zero matrices, the first point for adding two matrices, orders are equal. Orders are equal, must be equal. The order of A and order of B both will be equal, and same corresponding element should be add. Corresponding elements should be added. Okay. Example: A equals to A1, A2, A3, A4. B equals to B1, B2, B3, B4. Then A plus B is here. A1 plus B1, A2 plus B2, A3 plus B3, and A4 plus B4. Corresponding means what? First row, first column element. In the second matrix, first row, first column element. Next, first row, second column, first row, second column, like this. And A equals to 1, 0, minus 2, 5. 4, 7, minus 6, minus 8. Then we write A plus B. Yeah, 1 plus 4. Next, 0 plus 7. Next, minus 2, minus 6. Next, 5, minus 8. Yeah, we get 5, 7, minus 8, minus 3. In this way, we are taking the addition of two matrices. I hope you understand. In the same way, subtraction also will take. A minus B also we will take. Okay. And matrix addition satisfy the commutative property. A plus B equals to B plus A. This is called commutative property. Commutative. Matrix addition satisfy the associative property. A plus of B plus C. A plus B plus C. This is associative. And next, Matrix addition satisfy the identity A plus 0 equals to 0 plus A equals to A. This is identity matrix. Identity. 0 is a additive identity. 0 is additive identity. Next, A plus B equals to B plus A equals to when we are getting 0, then this is additive inverse. Additive inverse. Yeah, we are writing here A plus B equal to 0, then B equal to minus A. So minus A is called additive inverse of A, and minus B also additive inverse of B. Yes. Here matrix addition is satisfy the commutative, associative, identity, and inverse. When these four properties are satisfied, then the matrix is satisfy the group properties. Group means these four. Abelian group also. And the closure property is there. Closure property is there.
Sir?
Yeah. Okay. Yes, some more properties we'll discuss the next class. Huh?
Okay, sir.
I hope you understand this day.
Yes, sir.
Huh? This is new concept. Huh?
Yes, sir.
Do you have some idea?
No, sir, I don't have any.
Okay. How is this?
Yes, sir, it's fine.
Bye.